Hello and welcome. In this video, we're going to talk about some of the data manipulation instructions. So the first one we're talking about is the move instruction. And the move instruction just simply moves a copy of one data file element to a specific destination. So in this example, we are triggering a OSR, which is a one-shot rising, which we'll talk about in future slides. And when that triggers, we're going to move the value of N71 into the destination of N1215. So when this is executed and evaluated as true, our value on N1215 will become 7 once the value is moved. All right, on this slide, we're talking about the one-shot rising. The one-shot rising allows you to simply make something happen for one scan per change. So what that means is on each transition from false to true, the one-shot will execute one single scan. Whereas a typical examine if closed or examine if open is executing every single scan, and it's reading that every single scan, the one-shot will only execute one time. One of the ways in which a one-shot is useful is if you want to capture a value at a specific point in time. If you execute the one-shot, it will take a snapshot of an integer value or any kind of value that you want to capture, and it will store that into a destination register so that you can see what the value was at a specific point in time. That way, if the value is changing, things like temperature, pressure, values that can change over time, they can be captured and saved for a specific point in time. So let's say you have a shutdown event and you want that shutdown event to trigger a one-shot move of a register into a destination register so that you can keep history of what the value was when the equipment shut down. So that's just one use. There are a lot of different uses for a one-shot, but RSLogix provides that capability so that you can create scenarios where you need to execute something just one single time. So in this example, we have a input before a one-shot instruction. The one-shot instruction is addressed to a B3 bit. In this case, it's B33. And so when the rising edge from false to true on input 1, 0 goes from false to true, then our one-shot will execute. And the value at that time, when it switches from N71, will be added to N73. And the result of that math will then get placed into N75. So that will capture that value at that point in time and will not try to continuously add it as long as input 1, 0 is true. All right, the next instruction we're going to talk about is the masked move instruction. And the masked move instruction simply provides a hexadecimal mask for values to pass through before they get moved into their final destination. One way that you can use this is, let's say you have a set of 15 or 16 alarms that are triggering individual B3 bits within a word, and you want to use a mask to determine which of those alarms are enabled or not. So you don't want them to move if they're disabled, even if they're true. The fact that they're disabled should prevent them from moving to the final destination and triggering an alarm. So you could use a enable mask that allows you to then evaluate whether or not the alarm is enabled before it moves it to the final destination. So that's just one way to use it. There's a lot of different ways you can use a mask, but that's one of the more common ways of using a masked move. And so with the hexadecimal mask, the source data is passed through the mask bit by bit. So the hexadecimal mask determines which bits are then passed through to the final destination. So to set the mask bit, you just set the appropriate bit within the mask, and then you can choose which true values are then passed to the final destination. Okay, so I have my masked move set up in my RSLogix program, and I'm using a series of words to move values from one word through a mask and then to a final destination. So one of the easiest ways to set this up is by opening the B3 table, and we can see our bits laid out individually here. And if I were to set some values on our source, let's just set some arbitrary binary values and then trigger my masked move, you'll see that my destination does not change. So the destination stays at 0. So we'll go ahead and reopen our binary table. So to implement a mask, we're going to toggle our trigger to off, and then we're going to open our B3 binary table, and we're going to set up our mask. So if I set up ones for the entire mask, and this is one way you can do this, which is a little time consuming. So another way you can set the mask to all ones is by changing the radix from binary to decimal, and then to set every bit to 1, it's -1 because this is a signed integer data table, not an unsigned. So it's -1, and then we switch back to binary, and now we have ones for our entire mask. So now when we toggle our trigger, you can see that everything from B30 is then transferred to B32. So we'll toggle this off. We'll go ahead and change our B30 back to 0, and then trigger our bit back on. And you can see that my B30 word gets moved into B32. Now, let's say I only want the last 8 bits of this word to transfer. So the way that I can do that is by, first we'll toggle our trigger, we'll open our binary table, and we're going to set the first 8 bits to 0, and we're going to keep our last 8 bits set to 1. And now we're going to set a value on our B30 word. All right, so now what we should see is that only the bits on B30 from 7 down to 0 are going to get transferred to our B32 word. So let's trigger our trigger bit, and we verified that. So you can see that my first 8 bits are still 0, did not go through the mask, and the last 8 bits match the last 8 bits of our source word. Thank you for watching, and I hope this helps.